Hello friends, I welcome you in lecture number 2 on hypothesis testing. In previous lecture we have discussed about hypothesis testing procedure and we have seen how to apply this large sample hypothesis test for a population mean. Today also we will discuss one more question of this type in which we are doing a large sample hypothesis testing for a population mean. This question was asked in GTU summer 2020 exam. So first we understand this question. An auto company claims that the mean petrol consumption of its new 6-cylinder car is 9.5 km per liter, which is lower than the existing auto engine. It was found that the mean petrol consumption of a sample of 50 of these cars was 10 km per liter with a standard deviation of 3.5 km per liter. Test the claim at 5% level of significance. That is, we have to consider level of significance alpha as 0.05. So as we know that this is the problem of hypothesis testing, we have to test the claim of the company at 0.05 level of significance. Now the claim of the company is the mean petrol consumption is 9.5 km per liter. That is, this is the population parameter. We are given the value of population mean for this variable petrol consumption of a car and we have to test this claim. So our null hypothesis will be population parameter, which is population mean, is 9.5 km per liter, and the alternative hypothesis will be this population parameter is different from this value 9.5 km per liter. That is, mu is different from 9.5 km per liter, and we are given a sample of 50 of these cars. That is, we will consider n equal to 50, and it is given that sample mean, that is x bar, is given to be 10 km per liter, and we are given sample standard deviation, which is capital S. S is 3.5 km per liter. So here population standard deviation sigma is unknown, but sample size is greater than 30. So we have large sample test here, and we know that if population size is bigger than 30, then if sigma is unknown, we can replace sigma by corresponding sample standard deviation in the formula for appropriate test statistic. So now first we write down the alternative and null hypothesis. Null hypothesis is the statement related to the claim which is given in the question. So let H naught is, that is null hypothesis is that the claim is this mean petrol consumption is 9.5 km per liter. So that is population mean. Value of population mean mu is 9.5 km per liter, and therefore alternative hypothesis is a contradictory statement to this statement, and it is that mu is different from 9.5 km per liter. So first we have to write down what is null and alternative hypothesis for a given problem. Also we write that we have to test this alternative hypothesis at 0.05 level of significance. So alpha is 0.05. Now next step is we have to decide that which test statistic we have to use. So here it is given that sample size is 50, therefore we have a large sample. Also we are given the sample mean and sample standard deviation, which is denoted by value of sample standard deviation is denoted by small s. Sample mean is 10 km per liter and the sample standard deviation is 3.5. So here we have 10 and 3.5, and we can say that this sample size is large because it is greater than 30, and therefore we have a large sample. And we know that if we have a large sample, then using central limit theorem we can say that this variable capital Z defined as x bar minus population mean divided by sample standard deviation over square root of n is a standard normal random variable. So this is by central limit theorem. So we will use this Z statistic to test our hypothesis. Now we are given all these values, so we can calculate value of Z. So Z will be equal to x bar is 10 minus population mean, which we have assumed as 9.5. Sample standard deviation is 3.5 divided by square root of sample size, which is 50. So using scientific calculator I obtained that this value is 1.01. So the value of test statistic is Z equal to 1.01. Now in the next step we have to decide the rejection region. For that we will use the level of significance. Before that we can observe that our alternative hypothesis is mu is different from 9.5. So there are two possibilities, either mu can be less than 9.5 or greater than 9.5. So we have a two-tailed hypothesis test here. If we have not equal to sign in the alternative hypothesis, then we can say that we have a two-tailed test, and in that case our rejection region will be divided into two different regions having same area. Now because we know that this Z is a standard normal random variable, its probability distribution will be standard bell shaped curve, and at the middle we have value of Z equal to 0, and alpha is given as 0.05. Therefore alpha by 2 will be equal to 0.05 divided by 2, that is 0.025. So as we have discussed in the lectures of estimation, that if we have alpha equal to 0.05 and if we have two-tailed test, then the alpha area is divided into two equal areas having value alpha by 2. So these two areas are alpha by 2. The point corresponding to this is Z suffix alpha by 2. This is minus Z suffix alpha by 2, and alpha by 2 is here 0.025. So we can rewrite here minus Z suffix 0.025. So if our Z statistic is having its value in either of these two shaded regions, these two regions are known as rejection regions. So if our Z statistic is either bigger than Z suffix alpha by 2, or if our Z statistic is smaller than minus Z suffix alpha by 2, then we are in the rejection region, and we can say that null hypothesis is rejected. Now if value of Z statistic is in between these two values, minus Z alpha by 2 and Z alpha by 2, then null hypothesis cannot be rejected. So first we will decide this value Z suffix 0.025. Sometimes you will be given this value in the question itself. If it is not given, then you can use this logic. We know that probability that Z is bigger than this Z alpha by 2, which is 0.025. This is equal to this area, which is equal to alpha by 2. that is 0.025. Therefore, probability that Z is smaller than Z suffix 0.025 will be equal to 1 minus this probability, that is 1 minus 0.025, which is 0.975. So we will use the cumulative standard normal table. We will find out value of Z corresponding to this area in that table. So now I am going for cumulative probability table. I have to search for this value 0.975 and I have to identify the value of Z corresponding to this probability 0.975. So this is the cumulative probability table for standard normal random variable. The values in the table are probabilities that Z is less than or equal to small z. Here we are interested in the value of Z for which we have this probability 0.975, or we have to search for this area in this table. So I have to search for 0.975. So you can see somewhere here I will get 0.975 is here. So for that I have to identify value of Z corresponding to this row, and here this value of Z corresponding to this column. So here I have 1.9 on below Z, and here I have 0.06, so I have to add these two and I obtain that value of Z corresponding to given area of 0.975 is 1.96. Therefore here we obtain that Z suffix 0.025 is 1.96. So if it is not given, this critical value of Z is not given in the question, you can easily decide it from the cumulative probability table. So now we are sure that this value is 1.96 and this value is minus 1.96. So if our Z statistic has value which is bigger than 1.96 or smaller than minus 1.96, we reject the null hypothesis. And if value of Z statistic which we have calculated is in between minus 1.96 and 1.96, then we fail to reject the null hypothesis. So here the value which we have calculated is 1.01 and it is somewhere in between these two values. 1.01 is in between minus 1.96 and 1.96, or we can say that value of Z statistic does not fall in the rejection region. Therefore null hypothesis cannot be rejected. So here we can write that the value of Z statistic which is 1.01 is not in the rejection region. So therefore the null hypothesis cannot be rejected. Null hypothesis cannot be rejected. So here the claim of the company was that the mean petrol consumption of its new 6-cylinder car is 9.5 km per liter, and using this hypothesis testing we have tested the claim of company, and we can say that the test of the company cannot be rejected or null hypothesis cannot be rejected. So in this way we can apply large sample hypothesis test for a population mean, and here we keep in mind that here sample standard deviation is given, but because we have a large sample we are replacing population standard deviation sigma by sample standard deviation here, so that we have to keep in mind. But suppose we have a small sample size and we are not given population standard deviation, then we cannot use this standard normal distribution. In that case, this test statistic has a distribution which is not normal. It will be a t distribution that we will discuss in upcoming lectures. So this is all about this session. I have discussed this question related to hypothesis testing, which was asked in GTU summer 2020 exam. So I hope you like this lecture. Thank you very much.